everyone. Good afternoon and welcome to Brookings India. I'm Shamika Ravi. I'm the Director of Research at the institution. We are honored to have, first of all, a Cabinet Minister, Srimati Maneka Gandhi, with us. Maneka ji is the Minister of Women and Child Development, Government of India. Maneka ji, welcome to Brookings India. It gives me great pleasure to welcome the speaker for today, Vasant Dar, a friend and an extremely interesting, exciting speaker. Yeah. So Vasant is a friend and professor of information systems at New York University. Vasant has been working on cutting-edge research on big data, artificial intelligence. He has an incredibly fun TED Talk, which was recorded, I think, a month and a half back, and doing rather well. So Vasant is going to talk today about when should we trust artificial intelligence, and very appropriately, the discussant for his talk today is Ms. Anna Roy. She's an advisor at Niti Aayog, an IES officer of 92 cadre, and Anna is also the author of the national intelligence, the national article on artificial intelligence in India. So the format of the talk will be, Vasant will have 45 minutes to present his body of work, and Anna will subsequently discuss, and then we will open the floor for discussions. So Vasant, the floor is yours. Dazzle us.
Thank you. Do I need a microphone?
Well, actually, if
okay,
good,
let me
if
just.
you would like to move, we also have the mic.
No, that's fine. I'll use that. Thank you, Shamika, and thank you all for coming. I'll try and summarize roughly 25 or 30 years of work in 45 minutes, which seems like a reasonable thing to do, and try and reduce it to something that's simple and intuitive. My question really has been around when we should trust machines with decisions. The reason this question is particularly important is for the first time in our history, for the first time in human history, we have the capability to just generate huge amounts of data, and this just is growing exponentially. And at the same time, AI has matured to the point where machines can now learn autonomously from this data. They can learn, they can improve themselves, and they can make decisions. And that's new as well, right? So computers have been around for a while for supporting decision making. They do analytics, but what's different now is that we actually have machines making decisions and making good decisions, oftentimes better than humans. And so this raises the fundamental question, when should we trust them? Before I get to that question, and the other question I really want to address is something that's relatively new and I've been thinking about for the last 6 months or so, and that is, how will AI change the nation state, right? And that's what I'll end with, and I'll compare 4 nation states broadly with respect to their policies around data and how I see that impacting AI and the future nation state, right? But that's work that's still in progress, whereas this notion of trust is something I've been thinking about for a long time. So the larger questions, the AI questions for leaders are, what's a good mindset to think about AI in business and policy? And what does it mean to be an executive leader in the era of AI, right? So these are 2 broad questions that I want you to keep in the back of your mind. So why all the excitement around machine learning, right? And the reason is that there's something called supervised learning. So I've used color here to denote the buzzwords, right? So there's something called supervised learning, which has come of age. There's reinforcement learning, which works quite well, and we're making progress in unsupervised learning. So what are these things, right? So supervised learning is where every piece of data has an associated label with it that tells you something about that data. So for example, the bank that Shamika banks with has an estimate of her customer lifetime value, right? They might have a different value for Mudit, who's at the back of the room. And those are labels associated with the data. So Shamika would have a bunch of data, Mudit would have a bunch of data, and they'd have these labels, right? And the machine would figure out what is it about these people that impacts their customer lifetime value, right? So that's called supervised learning. Reinforcement learning is more where you get where there aren't labels associated with data, but the labels and the rewards come much later. And in reinforcement learning, you essentially get the machine to pit, you pit the machine against itself, right? So you start with two dumb machines, and let's say they're trying to learn chess or the game of Go. You probably heard of Alphago, around which there's a lot of buzz these days. Well, you get a machine to learn how to play Go badly, and it's playing against another machine that plays badly. And in reinforcement learning, they basically reinforce each other and they get better and better. The excitement around AlphaGo has been basically that, you know, several hundred years of human experience was discovered by the machine in a few days, right? And then some, in that the machine actually found new and interesting ways of playing Go that human experts hadn't even considered, right? So you have this additional bang for the buck you get with machines and data, which is that you can actually get machines to learn things that humans might not even think about. And unsupervised learning, I'm not going to talk about that. That's essentially, it's a very human thing, right? It's our ability to just learn without any kind of supervision at all, right? That's what makes us special. But that's, you know, machines aren't there yet, right? So an example of this is Google Translate, right? We've become so used to typing a sentence in one language and coming out in another, right? If someone had told me that we'd have a machine like this, 15 years ago, I'd tell them they were smoking something, right? It just would have been out of the realm of, possibility. And yet here we are, where, Google Translation is indistinguishable from human translation, right? That's huge. The other way to think about what's really going on is that there's been a paradigm shift from people programming computers to do something to machines learning how to do this, right? And this is where I got started in AI and finance in the mid-90s. The question really that I asked myself was, could I design a machine that could learn to invest as well as humans? Not program the machine, but get the machine to learn to invest. There's a big difference between those two paradigms. In one case, you think you know how to solve the problem and you write a program. In the other case, you have no idea how to solve the problem, but you've got lots of data, and you get the machine to write the program, right? That's what machine learning is really all about, and that's a huge deal. This shift from programming to learning, and big data is the grist for the mill. There's lots of labeled data cheaply available. For example, every document in Canada is in English and French. Well, feed them both to the machine. The machine learns how to translate between English and French, French to English, without knowing anything about either language, right? Amazing, right? So, and in the early days where, I don't know if any of you have played this game, but, 10 or 15 years ago, Google used to have this game where people used to play against, you'd pair up with someone on the internet, and they'd show you an image, and if both of you labeled it the same, you got points, right? And you felt good about that, right? And I spent countless hours doing that. It just gave me a thrill to do that. But I was really helping Google label images, databases of images, right? So to make them amenable for supervised learning. Now, more broadly, AI has all the excitement about AI is around the fact that AI has made a big dent in solving perception. And by perception, I mean seeing, reading, hearing, right? The kinds of things that humans are good at, our senses, right? And now you have machines which previously only worked if you translated the input or transformed the input into a representation that the machine could understand. That's gone, right? Because you now have a machine that can actually ingest input directly from the environment, whether it's a scene which it's seeing, whether it's a document it's reading, whatever it is, whether it's hearing something, right? It's the raw input that we humans are so used to dealing with that machines are now getting good at, right? And that has all kinds of really interesting implications for all kinds of things, right? It's for, for how machines will improve our lives, and how they'll displace us, right? There's all kinds of really interesting implications that flow from this particular observation that AI has made a big dent in solving perception, right? So it makes a big difference if machines can see, right? Which they couldn't, until a few years ago, right? So that's in a nutshell what the excitement is about, and so what are the implications for business and the nation state, which is one of the questions I started with. It's all driven by data of our activity, of our environment, virtually everything is recorded, unlike a few years ago. And this is all for machines to be able to learn on their own at scale. Right? That's what the excitement is really all about. So I've said, I've talked about supervised learning. What is it, right, in one page, right? Because I suspect there's a fair amount of diversity in this audience, right? So I just want to get everyone on the same page. And this is what it's all about, right? So imagine a bunch of data where you have a bunch of observations, and I'm calling the observations, I've divided them into two parts. One is the X, which is the state. One is the Y, which is the target, right? So that's essentially what the data consists of. And so in driverless cars, X could be the scene in pixels, right? The raw scene that it's seeing in pixels, and Y could be a human action, right? So in this kind of scene, the human driver turns left, turns right, brakes, does nothing. Or it could be the recognition of objects. You're looking at a scene in front of you, and you say, well, that's a pole, that's a car, that's a tree, right? That's what this might look like in vision. In healthcare, X might be the state of a patient or a treatment, and Y might be the future outcome, such as diabetes, complications, et cetera, right? Same kind of basic structure. In marketing, X might be the current set of observations from sensors, browsers, et cetera. So every time you open your browser, an ad pops up. Well, behind the scenes, that's what's really going on, right? They know something about you and what you're likely to be interested in, and that's what pops up in your browser, right? So with the objective of making you buy something, like, or click on something. So that's what happens in marketing. In finance, which is what I've spent most of my time doing, X is the current state of the market, and Y is the future return, right? So what's the relationship between the current state and what's going to happen in the future, right? I mean, I could go on, but you get the basic idea, right? That's what supervised learning is really all about in a nutshell. And what happens is the machine learns the implicit relationship in the X-Y pairs, right? So supervised learning is really about these X-Y pairs, and the machine learns the relationship on its own magically, right? That's what it's all about. And the learned relationship is then used, that's where the actionability comes in, to predict new cases, right? Because these are all observed cases, but you've learned the relationship, so a new X comes in, you predict the Y, right? And you can measure that, right? You can see how well you're doing, right? Are you, how much better than random are you is, for example, one measure of the performance of the model that's been learned by the machine. But machines make mistakes, right? And I use this example in the TED Talk that Shamika referred to, right? I mean, this is something we can all identify with, right? I mean, this damn autocorrect, right, just does the wrong thing, right? So they make mistakes and they can't explain their behavior as well, right? So two strikes against machines. They make mistakes, can't explain their behavior explicitly, right? So given this, the conundrum really is, when should we trust machines that will make mistakes? I've said can, but they will make mistakes, and they can't directly explain their behavior, right? So when should we trust them? Right? So that's a question that I answer. And I present a really simple model for answering this question. And it has two dimensions to it. One is, before I get there, so these are just examples of, so I wrote an article several years ago, should you trust your money to a robot? Should you trust your tax return to a robot? There's a new partnership between H&R Block and IBM, for the machines filing taxes for you automatically. Should you trust your child's education to a robot? There's an initiative in Bangalore aimed at answering this question, aimed at teaching 5 to 10-year-old kids math and literacy, right? Should we trust machines with this? Should you trust your transportation to a robot? Well, not quite yet, but we're getting there. Should you trust your sports refereeing or coaching to a robot? Maybe. We've just been watching the World Cup. How many mistakes could have been made? Well, the referees basically now could consult the machine, somewhere and decide what's really going on. Well, the computer could actually do a much better job than humans could if it's actually got the vision and is seeing what's going on. Should you trust your policing to a robot? Should you trust your healthcare to a robot, right? You get the idea, right? I could go on, right? So how do we make this decision? So here's how, right? So the way I look at the world is every problem lies on a continuum of predictability. For the statisticians here, this could be similar to irreducible error. And it varies between 0 and 1, right? So 0 means can't do better than random. 1 means it's a sure thing, right? So an example of a sure thing is, will Trump tweet tomorrow? Well, yeah, that's a sure thing, right? What he says is also almost a sure thing, or what kind of thing he says, right? So that's a sure thing. Whereas, if I ask you who's going to win the FIFA World Soccer, I don't know. It's kind of a crapshoot, right? The teams I'd sort of predicted are already out, right? It's a very difficult prediction problem, right? It's hard to do much better than random, right? Chances are if I poll you guys and we come back at the end of the soccer tournament, most of you will be wrong, right? So that's a problem that falls towards the randomness end of the spectrum. Now, as a practical example, an autonomous vehicle falls on the right-hand side of the spectrum because the physics with driving is well understood. The uncertainty here really comes around humans, right? The fact that these vehicles have to function in an environment dealing with humans, and we're kind of unpredictable, right? So that's kind of where that unpredictability is coming in, right? But the actual physics of vehicles and the dynamics and the kinematics and everything is really well understood, right? On the other hand, online targeting, very difficult prediction problem. It's very hard to know when to show someone something and that'll induce them to act. Investing, which is what I've spent most of my time hitting my head against the wall, is an even harder problem, right? It's almost random. There's very little structure in financial markets. And lending might fall somewhere in the middle, right? There's usually some pretty good models of lending, right? I think it's reasonably, it's much easier to look at a bunch of data about people and say, yeah, that's a good credit risk, that's a bad credit risk, right? So we can actually do much better in terms of predictability with lending, right? So you might think that this should be a proxability for when we trust machines, right? And traditionally in the literature, people have looked at this as a proxy for trust and say, well, let's trust machines on the right-hand side and not on the left-hand side. But as you can probably see already, that's quite inadequate, right? It doesn't really capture the nuance of trust. So what really matters? Well, what matters is something called the cost per error, right? So this axis, this horizontal axis, is a proxy for how often you'll be wrong, right? So on the investing side, you're wrong almost half the time, right? The y-axis is a measure of how bad are things when you're wrong, right? So this is the cost per error. So the consequences of being wrong are important too, right? So taken together, this offers an interesting picture of the situation. So for example, driverless cars are a very high worst case cost per error, right? And that's what you usually care about, is what's the worst case cost per error, right? Driverless car plows into a bunch of kids by mistake. Well, no, that's not acceptable, right? So that's a very high cost per error. In contrast, I might actually design a financial portfolio through hedging and various things where the risks are quite low, right? So even though it's low predictability, I can restrict my cost per error, right? Similarly, in online targeting, it's no big deal if most people ignore a message. Who cares, right? It doesn't really matter. Just show them another one, right? This is a large set of possible people you can show ads to, and it's no big deal if people ignore them. Lending, on the other hand, can be reasonably serious, right? I mean, it can take up to 20 to 100 profitable customers to make up for the loss you might suffer from one customer, right? Someone defaults on a loan of a couple of $1 million, that's serious, right? So the cost per error there is high, right? So you should be induced to make accurate predictions about who's likely to pay you back. So here's what the model of trust looks like, right? And it's a simple heat map, right? It's deceptively simple, right? You have a very dark green area on the lower right and a dark red on the top left, right? And so you should trust the machine on the lower right and not on the top left, right? And this makes perfect intuitive sense. If you think about it, right? If a machine is never wrong, you should trust it. No problem, right? But even if the machine is wrong on occasion, but the mistakes aren't hugely costly, that's still okay, right? But at some critical level of cost per error, you sort of begin to say, you know what, I'm not quite sure I want to trust the machine with this problem, right? And that's what makes up this automation frontier, right? So the automation frontier is, think of it as sort of a monotonically increasing line from the lower right-hand corner to the upper left, the lower left to the upper right, right? And we trust the machines this side to the right and below the frontier, and you don't trust the machines on the top left. So the dynamics, what happens over time is things like, I refer to AI referees. Well, they essentially, through data, they get better, right? The predictability goes up, the cost per error goes down. At some point you say, you know what? Let's just let the machine make the decision, right? So maybe the role of the referee on the field will change to one of maintaining law and order, right? As opposed to making the hard calls, right? The machines might actually make the hard calls because it's important to get that call right, right? There were several cases, by the way, in the World Cup I've been watching. I've been on vacation the last couple of weeks, and so I've done very little productive work. So I watched a lot of soccer, and lots of mistakes that referees made that could have actually changed the outcome of the match, the outcome of the tournament, right? So it's important to get that decision right. Right, so that's an example of a case where you cross the automation frontier into this trust zone. Similarly, cataract surgery. Many people now prefer that to be done by the machine because machines have become good, better than humans at most cases. Now, driverless cars similarly will keep improving, right? As we get more data, they'll improve, right? So this will move to the right, but regulation will play a key role as well. So regulation that increases the cost of error will move that up, right? And out of the zone. Regulation that decreases the cost of error, moves it down, will make it more amenable to automation, right? By the way, this doesn't mean that less regulation means less cost of error, right? It could equally likely be the case that no regulation might result in very high costs of error, right? So I'm not saying that less or more. I'm just saying the right kind of regulation can affect whether the cost goes up or down. In general, what we're seeing is, just one other thing, right? So let me just go back here, right? So some of you may have wondered, like, why did I just draw this straight line here as the automation frontier? And the answer is it was completely arbitrary, right? In fact, the frontier might look something like, oops, sorry. I got to do this again. Right? So, where does the automation frontier come from? And the answer really is that it reflects our conservatism with how willing we are to let decisions go to the machine. Sorry, okay, so a frontier like this basically says, I'm not going to trust the machine with much, right? So if we are less trusting of machines, this frontier will tend to hug the horizontal axis, and the green zone becomes smaller and smaller, right? But at some point, we need to evaluate the costs of error, the costs that machines make. So for example, if machines reduce accidents by 10 to 20%, that could be huge for society. But they occasionally make errors. We'll have to agree on a cost of error for those, to reap the larger benefits of society, and for insurance markets to emerge in that arena. In general, the goal of data science and AI is really to sort of push the problems towards the bottom right-hand corner of this heat map, right? And increase our trust in machines. There's some problems, like professors and policemen, that are still human, right? Because of the real-time sort of spontaneity that they require. This obviously implies that professors will be automated before policemen. So it'll be a while before we see robocops. And that's certainly true. I think most of myself could probably be automated. But there's certain problems here that remain in the red zone. Okay, so let me try and wrap up with some of the policy implications and the societal implications of AI. So here's how to think about, if you think about AI, it's really about algorithms and it's about data, right? Those are the two building blocks of AI. In my Hindustan Times editorial that I wrote a couple of months ago, I asked the question whether India has largely missed the train in terms of AI, because we really have no institutions that figure in the top echelon of institutions in AI. we've sort of largely ignored it. And so the question is, have we missed the bus? And the answer is no. And the reason for that is that algorithms are free, right? So someone else has already done the hard work, right? So most of these algorithms have emerged in North America, right? So a lot of that research has been done over decades. But these algorithms are essentially a public good now, right? They make their way into public domain libraries almost instantly, right? All of these really powerful algorithms, like if you guys want to go out there and go into all these Python libraries, you will find them there, right? Because scientists are motivated to publish and share, right? And so these algorithms are now freely available, right? So there's decades of research that have yielded these algorithms free to the rest of the world. Couldn't be more better, right? It's free. On the other hand, data are expensive, right? Very difficult to obtain. Now, ironically, a lot of this progress in AI and machine learning happened because data started becoming much more freely available, right? The fact that machines could sort of directly ingest images, smartphone data, all that kind of stuff, just freed researchers from that data bottleneck, which is typically what plagues AI research, right? And if there are people in the audience, you know exactly what I'm talking about. Getting the right data takes 95% of the work, right? That's where the problems lies, right? So algorithms free, data are expensive, and proprietary. Google and Tesla don't share their data for good reason, right? There's value in data. That's where all the value lies, not so much in the algorithms. And given this sort of scenario, my takeaway is that policy around data will shape future nation states, right? So these data policies will have a big impact on how nation states emerge and their character. So what do I mean by this, the last sentence? Now, if you look at sort of what's been happening in the last year, or even less, really, around data, there are essentially 4 models of data that have emerged in the last several years. So one I'll call data as an asset. And this is, how do you monetize data, right? And all of the business models of the internet giants are built around the notion of monetizing data. Yeah, you can have the service for free, but we're going to do what the hell we want with the data, right? Data belongs to us. Sure, you can do whatever you want on the platform, data belongs to us, and we'll figure out how to monetize this. And this has been a great deal for the internet companies, and that's evident from their market cap, right? These companies didn't even exist 20 years ago, right? And now they are the behemoths, right? Approaching $1 trillion in market cap, all because of data, right? I mean, if that isn't validation of the value of data, I don't know what is, right? So that's where the value really lies. And so the question there has been, how do you monetize, right? And these are rich societies, people have a lot of money, right? So if you can target better, you can extract more of the surplus, right? That's been, so that's the oldest model, right? Treat data as an asset, right? The European model sort of also considers data as a liability, right? There's actually a risk associated with keeping data around, right? And so the whole GDPR framework, this new privacy framework that's emerged in the EU, which they also call privacy by design, is really like, how do you really preempt misuse, right? So let's just think carefully about why I'm giving you my data and what you'll use it for, right? So why am I giving you my address, for example, if all you're showing me is how to navigate? Why the hell do you need to know where I live, right? Whereas you've all seen these apps, right? Like you use an app and they want to know everything about you. Yes, 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 right? I mean, I don't even look at them because I'm too scared to say yes to anything, right? So I tend not to use these apps, but I'm missing out on a lot of the cool stuff that comes with these apps, right? And I'm making the trade-off to be conservative, but most of my students say, well, I got nothing to hide. And I'm telling them, yes, you do. You just don't know what it is yet, right? So I just tend to be sort of much more concerned about that. And that's sort of, reflective of the EU framework, which is how do you really preempt misuse? The Chinese model of data is really for state control, right? So how do you link, how do you surveil, and of course, how do you monetize as well, right? But the Chinese priorities are really more about linking and surveillance. Now, I was having a really interesting conversation with a political economist last week, James Robinson, who's the author of Why Nations Fail. And he has a really interesting theory that he and his co-author have written in this book, which has to do with, the basic theory is that it's inclusive democracies that are stable, whereas centralized states and authority invariably fail. And he and I went for we were at a workshop, and we went for a ride to Goa and sort of into town, and so I started asking him, I said, what do you think about China? Doesn't that sort of present a problem for your theory? Because I think they're just killing it. They're doing really well, right? The innovation in AI in China and in general is through the roof. So clearly something's working for them, right? So this, so are you sort of overly wedded to this, democratic? Is democracy overrated? What's going on here? How does that square with your theory? And that discussion really got into whether assumptions about central control might be outdated, right? So in the old days, authorities didn't have the ability, the capacity to deal with a lot of information, right? I mean, it was just, there's no way you could do that, right? You can't maintain control like that. Whereas with machines, you do, right? Essentially, you have the ability to maintain a huge amount of control by letting the machine do all of the dirty work, all the hard work for you, right? So my question to James was, maybe your assumptions are, need to be questioned in this age of machines and data, because the state suddenly acquires the ability for massive control. And if they are clever about how they use it, they can use it for tremendous benefit, right? The risk, of course, is, as we all know, that it can be misused and you might end up with a dystopian society. But if they can avoid that, there's some real benefits to this sort of centralized model, where you can actually gather data and link it together, right? As scary as it is, right? So from the purposes of innovation, it's actually quite powerful. And then the last of these, which I'll call data for inclusion, and this was motivated by a talk by Nandan Nilekani at the same event, where I sort of viewed so essentially what his proposal was that we can empower people by letting them decide who and how and why they choose to share their data, and to do this algorithmically, right? So that I can specify as a user that it's okay for the State Bank of India to look at my credit transactions, right? It's okay for IIT Bombay to look at my transcripts, right? So I decide who's going to look at what data, right? So it's sort of an empowerment model of data. And this sort of flows out of, I guess, his notions of inclusion behind Aadhaar. And essentially what he proposes is the notion of a data fiduciary, where you have essentially a machine. The data fiduciary is essentially a machine, and it has an interface that lets someone specify who and what they want data shared with, and the rest of the stuff just happens automatically, right? So I call this sort of the fourth model, which is data for inclusion. So the way I look at the world, these are the four major types of models of data use that are emerging. So let me just wrap up with my last slide, and then we'll open it up for questions, which is that, so what are the implications of this for the nation state? So in the US, what's interesting is that the internet giants have become equivalent to nation states, right? I mean, the market cap of Apple exceeds the GDP of, I don't know, most countries. I mean, the numbers are just ridiculous, right? These, one of my colleagues refers to this as, how many of you belong to the nation of Google, or the nation of Facebook, right? That has 2.19 billion users, right? More than the Chinese population, right? So these people have people, well, citizens that that give them tremendous power just through numbers, right? And the fact that they know so much about these 2.2 billion people, they know almost everything about them, almost more than the people themselves, right? But this is presenting some difficult choices for U.S. policy and regulation, right? So there's sort of this, uneasy nexus between these internet giants and this sort of U.S. philosophy for free markets and all of that versus sort of a degree of discomfort that, maybe we should, think about regulating some of these companies. And I myself argued last year that, social media platforms should be regulated. And my reason for it was really quite straightforward, right? And I wrote this in 2017, several times. And the reason was, I don't know if you're familiar with this, but there was a paper that came out in 2014 by a bunch of researchers, including one from Facebook, that essentially showed that you could manipulate people's moods through their news feeds, right? So all of us are manipulable, right? That's not a surprise, right? But this was scientifically shown with a sample size of, I don't know, like several million or tens of millions, right? So massive sample size, solid statistical power, and to show that we could be manipulated, right? And my simple logic was, if it's possible and it's cheap to do it, someone will do it, right? And of course, we've seen what's happened, right? And there's been a real storm following the Cambridge Analytica scandal and the fact that they could have influenced the U.S. election, and now suddenly it's even Zuckerberg thinks that Facebook should be regulated, right? And I certainly think they should be regulated. I think we don't have time for this here, but I think the model of regulation that can be used for social media companies is similar to the model of regulation that we see in finance, in the financial industry, right? Where the objectives are simple. People want to know, are you treating customers fairly, right? Not giving preferential treatment to customers, that's a fiduciary duty. Are you not doing weird things like destabilizing markets, right? So people in the financial industry care about simple things, treating people fairly, not screwing up the system. How they measure that keeps changing, right? So regulators show up every once in a while. I created a hedge fund that I run. Regulators show up in my shop and say, well, show us that you're not favoring clients. And I'm saying, okay, what period do you want? And they tell me. I press a button, all the trades come out. I show them that I'm compliant, right? And there's no reason why a similar kind of setup couldn't work in the social media industry, right? Companies like Facebook and Google are in the best position to be detecting these kinds of things. They just haven't had the incentive so far for doing so, right? Until middle of last year, Zuckerberg thought that the idea that anyone could have used Facebook for manipulating anything was ridiculous, right? There was continuous denial for a long time, until they suddenly said, holy shit, like this has really happened to us and we need to take this thing seriously. So this is, it's going to be interesting to see how regulation unfolds in the US, but there will be more regulation, especially around trying to contain some of the risks that arise from data in social media platforms. In the UN and Japan, I think the regulators face a big enforcement challenge, right? If you read the GDPR guidelines, they make a lot of sense, but it's English, right? It isn't clear to anyone what that really means, right? It isn't clear to anyone how strictly they'll be enforced, right? It isn't expressible as code, right? It's written in English. And so the challenge will really be in interpreting this stuff. Like, did you really use someone's data inappropriately? Can you prove it? Right? It's a messy ground, but I think the intent is good. China, interestingly, in my mind, has a big innovation advantage, considering that data leads to better algorithms, we lead to better data, so this is a virtuous cycle, right? So given China's essentially unbridled policy around data use, they're best positioned, in my mind, for innovation around data. But they face the risk of misuse, they face the risk of creating a really dystopian society, but that's not something that they're worried about at the moment, because they're really focused on the advantages that they can get from the data, and will worry about the misuse later, if at all. And in India, it's sort of more of the enhancing state capacity for basic business services and making business, basic digital services public goods, right? So you can build payment systems, education system, all kinds of systems. So the mentality around, in India seems to be around creating an infrastructure that can serve as a public good, which can spur innovation, inclusion, and that kind of stuff. So that's, in a nutshell, what I see as emerging models of data that'll drive the nature of the state that emerges through these policies. And I think, as I've said or implied, this will lead to very different kinds of nation states. How exactly they unfold will be an interesting thing to observe. Thank you.